My name is Pamela Schultz, and I have a background in chemistry. I have an undergraduate degree in chemistry, and I've always been very interested in environmental science. And so I got a master's in environmental science and engineering, and recently went back and got my PhD so that I could teach, and really wanted to become an expert in the field of environmental chemistry and environmental science. The course is an applied contaminant transport modeling and looks across multiple media. So rather than focusing in on one single media, trying to look at the connections between air, surface water, groundwater, seeing how contaminants move through environmental systems, and trying to give people a better sense of globally how chemicals behave. One of my goals in the class is to provide people with a sense of when they hear of a certain compound that they can immediately have some idea of, okay, I remember what that structure is, I have some idea of how that compound behaves, and I have some idea of whether or not that might be an issue in an environmental system like groundwater or surface water. One of the things that I really hope that people take away from the course is also understanding, not only getting a better sense of the chemistry, but understanding some of the uncertainties involved in using chemical data, how to interpret chemical data. And I think we tend to want to look at a number and assume that that is the number, that is the answer. But in fact, a lot of what we do in environmental systems has uncertainty associated with it. In terms of who would benefit from taking this course, I'd say environmental professionals who need to have an understanding of chemicals, an understanding of contaminant behavior in environmental systems. There's an emphasis on remediation and how chemicals behave in subsurface systems, but also trying to look at environmental chemistry in general and how chemicals behave. In terms of the people who come to the course, it is a varied background. There'll be people from the health department who want to have a better understanding of fundamentals of chemistry and how contaminants behave. Also, people who take the course are people who are in environmental remediation, who maybe just haven't had a chemistry course in a while, want to get back to the fundamentals, as well as understanding what some of the current state of the science is in terms of understanding contaminants. Well, one of the students in one of my classes had pulled me aside and indicated that one of the things that they found really helpful was just that in their work they constantly were throwing around names of chemicals. So they had heard certain chemical names over and over and over again, but actually had no idea what the structure was and had no idea how they behaved and where the names came from. And that's one of the really important topics, I think, in the class, is just to see a name and recognize it and be able to understand what that compound is. I think one of the gaps that the class helps to fill is that a lot of people took general chemistry, maybe they're an environmental professional in the field, it's many years since they've taken that. A lot of people have taken the general chemistry though and haven't taken organic and other advanced inorganic classes, and this course isn't meant to fill that gap completely, but it does give a leg up to people who have to work with organic compounds and metals in a way that maybe just a pure introductory chemistry course doesn't give you that background. I think this course is necessary because the trend in the environmental field is to try and look across media and to get people who are focused on one media to be able to talk to people who are focused on other media. And it really, again, a more holistic view of environmental systems.